Hello guys, in today's class we will cover the important topic that is feature scaling on Bayes theorem. Okay, so first we cover the feature scaling. Okay, so feature scaling is a pre-processing technique used to standardize or normalize the range of independent variable in the dataset. Okay, it helps in improving the performance and conversion speed of machine learning algorithm. Okay, it helps in improving the performance and conversion speed. Okay, so first we notice in feature scaling, suppose I give you an example. Okay, okay. Suppose it is a data set that is present as age, and here is present weight, and here is present height. Okay. Height in present in centimeters, weight in present in kg, and age in present in year. So here suppose data set value 24, 28, 30, weight is 70, 80, and 75. And here height is 170, 180, and 150 like this. So here you notice, so if you draw the regression line of this, so it looks like this. Mm, suppose. Okay. And the pointer like this. Okay. So here now for feature scaling, we will convert this weight or height or age to some transformation that is -3 to 3 or 0 to 1. Okay. For transforming to this dataset -3 to 3 on 0 to 1, that is called feature scaling. Okay, so types of feature scaling. There are four types. That is, first one is the standardization, Z-score normalization. Second one is the mean max scaling. Third one is the robust scaling. And last one is normalization, that is L to 4. Okay, so standardization scaling, that is scale features to have a mean of 0 and a standard deviation of 1. Okay, so if you notice this standard scaling, that is xi minus mean, that is x bar whole divided by sigma, or you can call it as xi minus mu by sigma. That is the standard normal distribution. Standard normal distribution. Okay, okay. So second one, that is mean max scaling. This rescales features to a fixed range, usually between 0 to 1. Okay, so it is a image application. It is a image application used for 0 to 1. Okay, so the maximum scaling formula is x minus x mean whole divided by x maximum minus x minimum. Okay, it is your min max scaling. Now you notice robust scaling. Uses median and interquartile range to scale features, making it robust to outlier. Okay, so in robust scaling, if you notice the formula, that is xi minus x median whole divided by x 75 minus x 25. What is x 75 or x 25? That is, suppose quartile 1x whole divided by q3x minus q1. Okay, we will notice what is q3, what is q1 in dendrogram. Okay, so after that, normalization, that is L2 form. Scale features to have a unit norm, that is magnitude, useful for algorithm relying on distance. Okay, so now the next topic is when to apply the feature scale. So algorithm that rely on distance matrix, example k nearest neighbor we will discuss, support vector machine we will discuss later, benefit for feature scale. Gradient-based optimization algorithm. In some distance metrics, we use feature scaling, and in gradient-based optimization algorithm, that is linear regression, we will already discuss logistic regression or neural network. We'll discuss in deep learning. Okay, that is the last unit. And require feature scaling for optimal performance. Okay, so you have doubt why feature scaling. Algorithm like gradient distance convergence faster when features are scaled prevents features with large scale form dominating the learning process. Ensure fair comparison and weighting of feature in the model. Okay, so you have doubt feature scaling workflow. How the feature scaling work in ML. Okay, so identify the numerical feature that needs scaling. First one, find the numerical feature. Okay. Then choose appropriate scaling method. Choose scaling method. And third step is characteristics. That is, apply the feature scaling to the training data transfer and testing data using the same scaling parameter. Learn from the training data to maintain consistency. So, you remember, always scale feature before applying algorithm that are sensitive to feature scale. That are sensitive to feature scale. Okay. Consider the distribution of data and the presence of outlier when scaling a scaling method. Okay. Validate the impact of feature scaling on model performance through experiment and evaluation metrics. Okay, so now we'll discuss the important algorithm in machine learning, that is naive theorem or naive classifier. So in naive is a probabilistic classification. It is totally depend upon the probability. It is a best application of probability. Based on Bayes theorem, with an assumption of independence among features, widely used for next classification, for spam filtering, and recommendation system. It is widely used in classification technique, also in spam filtering, for example in mail spam, and for recommendation system. Okay, so in neighbors classification, we'll discuss some probability. So, you know some basic concept of probability. Suppose we discuss here some independent event. Okay, independent event. You know what is independent event? Okay, suppose rolling a dice. Rolling a die. The outcome will be 1, 2, 3, 4, 5, 6. like this. Suppose the probability of 1 is 1 by 6 and probability of 2 is that is also 1 by 6. Like this, it is the independent event. So second one is dependent event. Okay, so dependent event. In dependent event, what is the probability? Suppose I give you example, that is what is the probability of first removing a orange marble, a orange marble, and then a yellow marble, yellow marble. Suppose you have three orange marble and two yellow marble. Okay. So answer. Okay. So here you notice the probability of orange marble. Here you remove the total is 5 and you remove 1, that is 3. So it is first event. Okay. And for second event, that is remove yellow marble. Already orange is removed. So it is 2 total number of yellow marble present, that is 2, and total number of marble present, that is 1 marble in remove in first event. So total 4. That is the second event. So probability of orange and then one yellow marble is removed, that is probability of orange into probability of yellow with giving orange. So that is 3 by 5 into 2 by 4, that is 3 by 10. Okay, that is 0.3 is answer. Okay, so you know the formula P of A and B equal to probability of A into probability of B by A. Okay, so it is the basic concept of probability, that is the independent event and dependent event. Okay, so now we'll directly discuss the Bayes theorem. Okay, so probability of A and B equal to probability of B and A. Okay, so probability of A into probability of B by A equal to probability of B into probability of A by B. Okay, similarly, probability of B by A equal to probability of B into probability of A by B whole divided by probability of A, or probability of A by B equal to probability of A into probability of B by A, or whole divided by probability of B. Okay, it is your formula of Bayes theorem. Okay, so here, okay, here probability of A by B, that is probability of event A given B has occurred. Okay, Okay. Similarly, probability of B by A means probability of B given A has occurred. Okay. So here you notice the probability of A by B is probability of A by B is that is posterior probability. Okay. And probability of A is likelihood probability. And probability of B by A is failure probability. Okay. Now we discuss, suppose it is a some data set given. Okay. So data set, in some data set there is some features is present. Suppose x1, x2, x3 like this, and some output will present. Okay. So some value in present in x1, x2, x3 like this. Okay. And here some output is present, that is yes or no. Yes or no. Okay. Like this. Okay. So if you calculate the probability of y, that is s, given the features is x1, x2, x3. So the formula of Bayes theorem is probability of y into probability of x1, x2, x3 whole divided by y, or whole divided by probability of x1, x2, x3. Okay. So, okay. So now we elaborate the formula, that is probability of y into probability of x1 whole divided by y, x1 divided by y, into probability of x2 event occur when b is occur, into probability of x3 when s is, and whole divided by probability of x1 into probability of x2 into probability of x3. Okay, so now we elaborate this. So probability of, that is s, x1, x2, x3 equal to probability of s into probability of x1 by s into probability of x2 by s into probability of x3 when s is equal. Okay, whole divided by some constant, that is this probability of x1 into probability of x2 into probability of x3. Or similarly, you calculate the probability of no, which given x1, x2, x3. Here probability of no into probability of no, sorry, x1 when given no into probability of x2 given no and probability of x3 given no, whole divided by same, that is probability of x1 into probability of x2 into probability of x3. So it is also a constant. It is constant and it is also constant. If what is the highest probability, that is the answer. What is the highest probability? probability, that is the answer. It may be yes or it may be no. Okay, so it is the example of Bayes theorem. Okay, like this in real life example, some data set will present like this, and you predict the output is yes or no. Okay, like this. You first calculate the probability of yes with respect to the features, all independent feature, and we calculate the probability of no with respect to all independent feature. Then you notice which probability is more. If probability of yes given all the independent feature is more, then the output will be yes. Otherwise it will be no. Okay, so now Naive-Bayes workflow. So how the Naive-Bayes is work in real life? So prepare the dataset with feature and class level. Choose the appropriate type of Naive-Bayes based on the data characteristics. So we notice types of Bayes theorem. Okay. So train the Naive-Bayes classifier using the training data. Evaluating the model performance using metrics like precision, accuracy, and recall. Okay, so advantage and limitation of Bayes theorem. That is, advantage of Bayes is simple and computationally efficient. Okay, it is simple and computationally efficient. Second one is it handles the high dimensional data well and perform well on large data set with categorical features. Okay, so we notice for spa. Okay, the male is sperm or not. It is an example of Bayes theorem. So limitation of Bayes. So first limitation is the strong independency and assumption may not hold in real world dataset. Okay. And second one is limited expensive for complex relationship among features. Okay. If the features output features will maybe very large. That is, suppose the output may be the 0, 1, 2, 3, like this. Suppose it is maybe your uh, first class, second class, third class, fourth class, like this 10 class, we assume. So here the calculation is very complex in neighbors, sensitive to irrelevant or redundant features. Okay, so types of neighbors, first one is the Gaussian neighbors. Okay, here the assumes feature follow a Gaussian that is a normal distribution. You know normal distribution. So the features are follow the normal distribution. So next one is multinomial neighbors that is used for discrete features. Example word count in text classification. That is this classification is used in NLP. Okay, natural language processing. So last one is a Bernoulli neighbors that is depend upon the binomial distribution. Okay, so suitable for binary feature that is the example presence or absence or yes or no or spam or not spam like this. So now we complete the today topic that is first one is the feature scaling and second one is neighbors. Okay, so thank you.